Right. But first of all, that photograph is VNG Lyndhurst back in about 1980. I don't make stuff that neat. I don't put stuff in a rack that looks like that, as you'll see later on. I suppose I thought I might just spend a couple of minutes, that means I don't have to speak less about my own stuff, about the when the first shortwave transmission was. And it's really early because if you follow history a bit, when Maxwell worked out his equations that there was actual electromagnetic radiation, and Hertz did the experiments, that was at very short wavelengths, about 80 megs or whatever, of course, of the size of the things. They did the experiments. Then the practical experimenters started with the VHF, of course, the size was manageable, and they worked out they could put in a high antenna on Earth mat, and they got much better results for the equipment they were using at the time. So if you move on to 1901, when Marconi did he got his supposedly, it all seems a bit dodgy to me, because when Marconi transmitted from the US to Ireland or whatever it was, there were no observers, just him and his offsider. I mean, they could have made it up. And I often think, and the physicists at the time said you can't get that distance, and you couldn't without any enhanced propagation at the frequencies they were using. They couldn't have got across the Atlantic Ocean. So I'm pretty sure what was happening, their transmitter was 20, 30,000 kilowatts of just spark, just interference generator. So they would have had, there would have been massive amounts of energy going right up into the mid-high HF spectrum. Probably there's tens or hundreds of watts of frequencies around 20 megs or whatever, you don't know. But it was just a noisemaker. The fundamental was somewhere in the broadcast band. People have looked up the specifications, and that's where its natural resonance would have been, but massive amounts of power at other frequencies. So I suspect that with so much going on, and they did the tests in the daytime, which is stupid. At nighttime, they could have got across from the fundamental, but there would have been enough power just around the MUF, which of course is the most efficient way to get somewhere. Whether the MUF was 6 megs, 12 megs, 18, it wouldn't matter, because it was massive amounts of power. So I'm pretty sure when he supposedly heard the signal, he's using a coherer, which is a totally inefficient way of listening, and he, in desperation, stuck an earphone in series with it that would have worked like a crude detector, and heard the S signal. So I think he was probably hearing a harmonic of the main transmitter going via skywave, via propagation. Probably it might have been a very strong signal if it was if there was enough radiation at the MUF to get down to where he was going. So so that's the short. That was probably done on shortwave. If it was done at all, it's all a bit dodgy. And then in the early part of the 1900s, ships used spark, and they used anything above 500 kc was just considered rubbish. Everything, all the important stuff was down below 400 kilocycles. But they did, once they worked out how to tune stuff, they did put a band. They had a transmission that was maybe 50 kilohertz wide rather than 500. They tuned stuff up. They did have a band at 2 megs, and this was for short range talking to a ship they could see, or in the harbour talking to the harbour master or whatever. They'd use a low power transmitter on 2 megs, and it wouldn't wipe out and interfere as much as using the lower frequencies. So they used 2 megs. It was just basically line of sight as far as they were concerned. But the operators did notice that sometimes at night they'd hear a station from the other side of the world on 2 megs, which was unbelievable, and they'd report that in. It can't happen. We know signals don't go that far, but they were hearing through their primitive equipment propagation, worldwide propagation sometimes. But that was it was only later, when the valve was introduced, they could magnify things 1,000,000 times, that HF sort of started going. And the other, I will get onto my station eventually. The other story we hear is that the hams were kicked off the good frequencies, and they had to make do above 1.5 kilohertz, 1.5 megs, and they messed around there and went higher and higher and got more and more results and went around the world and all sort of stuff. Well, that's partially true, but Previous to that, the engineer at KDKA, which is another myth story, first real radio station in Pittsburgh in the USA, and a lot of places could have had that same thing. But anyway, he was this was in 1920, and radio had just started off, and he was working on the transmitter, and a lot of DC power was going in, and a lot of RF power was coming out, but it wasn't working, wasn't getting the coverage you would have assumed he would get with that power on the frequencies, on the 860 kilohertz. So he suspected a lot of power was harmonics, and he had wave meters and stuff, but he wanted to really find out what was going on. So he built a receiver that sort of went up to 6 megs, which was in that day was unbelievable. Like, nothing was above 2 megs. Why would you want to build something above that? Because there's nothing there anyhow. And to get those old, antiquated valves to work at a high frequency is a pretty hard thing to do. Anyway, he got a receiver that worked quite well into the HF spectrum, took it to the other side of town, and he turned it on, and he could hear his station louder on the harmonics than he could on the fundamental. So he said, yeah, obviously. So he did some work and made his transmitter so it was mainly putting stuff out where it was meant to. But the interesting thing is, as well as hearing his station, he could hear stations from the other side of America. There's about 50 medium wave stations operating at the time, and he could hear them in the daytime well further than their daytime coverage on their harmonics around 5.5 megs or whatever. And of course, at night, the whole band was just full of cacophony of stations all over each other that you wouldn't hear on medium wave. And he thought, well, obviously shortwave seems to work. And they did actually put a shortwave service there. And a lot of early broadcast stations had a shortwave outlet as well. And they did in Australia, a lot of our commercial stations did. They thought, here's a good way to broadcast, low power, simple antennas, goes a long way. But of course, it's unpredictable and it's useless for local coverage and all that sort of thing. So it was later on in the 20s when they had international broadcasting, and the international domestic shortwave, as opposed to trying to broadcast to other countries and things, is in Australia. We've had it for quite a while. As I said, a lot of stations had a shortwave outlet for a few years until they worked out it wasn't really paying much. Of course, their sponsors and things are in the city they're broadcasting to. What's the point of spending money transmitting interstate or whatever? So anyway, the ABC started, they had the service overseas, and in the 40s they started shortwave broadcasting to the inland, VLH, VLR at this site here, and also Queensland had VLQ at about 4.8 megs, I think, and Perth had really strong 50 kilowatt. Well, these stations were only like 10 kilowatts. Perth had a 50 kilowatt station, VLW, beamed out to the Kimberleys in Western Australia, and that was like on 15 megs, so it got out really well, and they all got turned off in the 1980s. Sydney had a station, VLI, and it was designed to give people in the northern part of New South Wales up the coast in the summertime when there's lots of static, a coverage. Of course, they often couldn't hear it because of the noise. And it ran out of Sydney, and it was 1 kilowatt VLI, and it ran up to the mid 80s. And I remember, if you want to listen to what was happening on 2BL in Sydney, you just dial up 6010, and you could hear Sydney as clear as a day in Melbourne most times of the day. And it was a kilowatt from Sydney. And I remember being in the Kimberleys and listening to VLR and VLH from Melbourne, and walking to a shop or a store in Derby or somewhere, and they had a radio on, and it was listening to shortwave from Lyndhurst, and they were listening to the Victorian news and the Victorian weather. Of course, it was a relay of 3LO, so they were listening to Victorian programs, could have relayed up there. And I remember being in the Grand Canyon. I took a receiver down there, and I could hear 3LO on whatever 15 megs, I think it was, from Lyndhurst. which I thought was pretty good. Those pre-internet days, to be able to listen to your local station when you're overseas was pretty good. And so anyway, that's the story about a background of shortwave that I've sort of been involved in a bit. I suppose we'll go to, I never worked in Radio Australia or anything. I did work as a tech op in Broadcast House, the domestic service in Melbourne. And I used to occasionally fill in for a month or something over the road, Radio Australia. And Radio Australia was considered, it was a bit of a gentleman's club, you know. If you made a mistake there, nothing happened because no one's going to ring up from overseas and say you got the wrong program or something's wrong. So if you worked in the domestic at 3LO or something, if you made a mistake, you got the red ticket, and whether you made a mistake or whatever, and you get a blast. But it didn't seem to matter too much on shortwave. On Radio Australia, puts the wrong program out or leave it blank for a while. Eventually, Shepard would ring up and say there's nothing coming in, or I think you've got the wrong program. But no one was too worried about it. Whereas in the home service, the studio supervisor would come up and they'd have this slip. It said wrong program, marred program, and no program. That's right. So if you made a mistake, you'd get a little ticket, and that would be bad next time you go for your assessment because they'd say you've made this mistake or something like that. Anyway, that's all by a bit of history. I think I've got a few little maybe photographs of Radio Australia stuff, which may not have been. Let's have a look at this. Oh yes, the thing there, and organised this not particularly well, but we'll see. Here we are. That's one of the come up. I think there we are. This is over the road, which I used to consider like a. Where's the enlarging thing here? Oh, it's already enlarged. Yeah, there's one of the little booths, little man there with his nice brill-creamed hair and a bit of a suit and stuff. And that was one of the booths where you'd listen to landlines coming in for overseas, and you'd record tapes, any news items that you thought or they thought might have been interesting to replay or whatever. So that was like you'd sit there and do that sort of thing. And I think there's another photograph here of the same or similar room. So yeah, so we got the ubiquitous. That was very similar to the layout in Broadcast House as well. The desk, they were sort of modern desks at the time. A tape recorder rack and the ubiquitous Type 3 speaker was there, and of course radio announcer in the studio. There we are. They were quite nice studios, very big glass panel. Working there wasn't as interesting as home service, because often they're talking a foreign language, so you couldn't really understand you couldn't take a lot of interest in the programs because you didn't know what was being said. And I think there's one further, one of a radio, where we are, operator in comms room. Oh, well, maybe it's not there. Maybe it's... move that down there. Anyway, of course, we all know what happened to Radio Australia. This is a famous photograph of Nigel Holmes, who was the frequency manager at the ABC, who liaised with Broadcast Australia to work out frequencies and stuff like that. And when they closed Radio Australia down, he'd been retired for a few years. So it's a good thing they got someone who wasn't working in the place to close it down and press the last button. And so quite often Nigel would go up to Shepard and look around there and talk to the guys, and he'd go back and work out what frequency they're going to use and stuff like that. And a few times I went up with him, and just for a bit of a trip really, because I didn't have anything to do with it. And we'd look around the big transmitter site and stuff like that. And anyway, when they closed it down in 2017, it was, when I'd been there previously, they were very friendly and they showed you everything. You could do whatever you liked. The day they were closing down, they didn't, obviously it was political, and they didn't really want anyone there, but some big people, like people from the ABC and a few local personalities came along, and they let them in. the local TV station wasn't allowed in, and they didn't really want people to video or take photos, but people got their phones out and started doing it. So they really couldn't do much except do it. And they were just going to turn it off in the middle of a program like that. But they convinced people to send the tuning signal up, and it was done when it had a bit of a ceremony about it. So that's the last day of Shortwave Australia, of Radio Australia. I just picked Shortwave Australia out of the air. Probably is not a good name. I should call it something else, I think. But anyway, big power. People think shortwave's big power. And the interesting thing is that if I have a look at the thing here, there we are. There's a good thing. You know, when I was telling people, oh, I'm going to, get a shortwave license and broadcast, and they, you're talking rubbish. You've got to lend yourself. You need at least 10 million watts. You need at least 100 kilowatts to do broadcasting. You can't 100 watts. What are you talking about? You're laughing. It's a blah blah blah. But I think there's yes, on there. Now this is the spectrum. I just did this the other night. Not any just night. It wasn't a particularly good night. Not a particularly bad night. Taken off the SDR. This is the one up at Hunter Valley, New South Wales, VK3ASE. It's a particularly good one. A lot of the online SDRs are crap, basically, but this is a really good one. And you can see the spectrum there from 4 megs, and there's some stations, radar, and then the big boys up there on the 49 meter band. Now that's my signal on 4835. And see how it compares. I know it's only in New South Wales. These guys are probably from all over the world or whatever. But that's my signal there, and that's the 49 meter band with all the big boys. So that's 100 watts compared to probably 50 kilowatts, but the other side of the world. But still, it's there. And so I think I used to do experiments at home on these frequencies. And before I moved up here from a suburban block, and I was amazed at how well you get out with low power. Of course, some nights, I think the difference is if you're running a service that's contracted, or you've got to put out the propaganda or whatever, and you want 95% coverage of the area that you're meant to cover, you probably do need 50 kilowatts. For a really bad night to get over that, or static or jamming radar, you need the big power. If you're happy just to do it, and it's listenable in most places 70% of the time, you don't need so much power. And the other thing is that when you look at this in real time, the signal strength's going up and down by 30 dB anyhow. So effectively, sometimes if I was running 100 watts, it goes up and down as much, like it's equivalent to having a transmitter with going from 100 watts to 100,000 watts, 30 dB. And it's going up and down like that all the time. So if you have more power, obviously you've got a better starting point, but it's sort of a bit, it doesn't make as much difference as you might think. Of course, if a really bad night, the static and the propagation's bad, it's just the way it is. You can see the radar, it does come down to me sometimes, but not always. It usually sticks above 5 megs. Sometimes I get a buzzing night. So that's that. And if I think there's the other end of the spectrum, this is the 2 meg end of the spectrum, and same thing here. That's the AM broadcast band, and there's no one on 160 meters, obviously, that time of the night, and that's the VMC weather, either from Wiluna or Charlieville, and that's my signal on 2310. So I mean, it's a bit misleading because you see that. I think the guy's got a filter on the broadcast band, and it's probably down 10 dB or something, and slowly rising up to the normal level in the HF spectrum. But that's 100 watts on 2310 compared to the broadcast band. So, and I like 2 megs because it's out in the middle of nowhere, and radar doesn't get down there. You're not going to get China coming over the top of you or something like that. So initially I was going to concentrate on 2 megs, but 60 meters is more efficient in some respects. And a lot of people have interference and stuff on 2 megs, which doesn't improve it all that much. And this is like the whole spectrum, I think, of it's squiggling. There we go. Yeah. So there we see, the whole spectrum from the AM broadcast band. This is from, I think, Hunter Valley as well. AM broadcast band. There's my signal there. There's something else. That's either some interference local to the SDR, I think. Anyway, you can see the story. There's my 4 meg signal. There's the 49 meter band, and there's the 41 meter band. So, you can say between the broadcast band and the 49 meter band, my 100 watts are the 2 strongest signals in that part of the spectrum. And that's like, 1,000 kilometers away. So, not too bad. It's not, and the other thing is you can't run big power. The cost of power now is just ridiculous. So 100 watts, probably the rack, everything running about 800 watts or something to run everything. I could go and go to SRK transmitters in Melbourne, and they do a great job. You can spend about $5,000 and get a 100 watt transmitter. Just tell them what frequency you want it on. And they've got a nice 1500 watt one, which, about that size, Class D, really efficient. And all you have to do is plug audio in. It's got its own built-in audio processing. It can be communicated by the online, so you can have your phone, you can be anywhere in the world. And you can just, dial up and change modes, change power, turn it on or off or whatever, check everything's going okay. That'd be great to have something like that, but it costs about 20 grand. So I'm just using what I've had, the equipment I had on 160 meters and 80 meters back in Melbourne, that I've built over the years. I'm just using all that. And it's been going now for 2 years, and really, it's been very reliable, I must admit. So people think it's old-fashioned using valves, but I just use what I'm using. Okay, where we go to now? When I first moved up to Neilborough, and I'll put that spectrum up as a standby slide. To get the licenses, what happened was there were some domestic licenses available to shortwave. Above 5 megs, it's really hard because the ITU gets involved. But below 5 megs, the ACMA basically can say yes or no to anything. And there were a few shortwave stations. Craig Allen, I think he was starting a shortwave service on 5050 back about 10 years ago. You might remember that. And he was going to have a service and do it in a sort of quite a professional way. But unfortunately, he died. So it finished. And then when Radio Australia and the domestic shortwave service of the ABC closed down, there are some additional channels. So a lot of people bought these or got hold of these channels thinking they'd be able to sell them on to, a religious broadcaster or somebody else and make $1 million, but it never really happened because no one could care less. And it's just sitting there. So I did approach the ACMA now. If you want a frequency or something, you have to approach a contractor who works, and they work out what they want. So if you want to build a cell phone tower with 1 million things, you get an engineering contracting company, they work it all out, and when it's put together, it goes berserk. The ACMA say, well, it's not our problem, it's the contractor, you go and complain to them. So to get frequencies is, if there's frequencies available that someone's got, it's not so hard to get them, you can transfer them. But they don't really like making new frequencies that haven't been used for that purpose before. But anyway, I was able to contact Peter Tate, who has quite a few of these frequencies and has got a station running on 4970. So he's been running that for a while. So he's another person on domestic shortwave up there. and there's another one in the Gold Coast, Raymond Island, I think. But there's a couple around. A few are active, a few aren't. People are sitting on the licenses. But anyway, I was able to make a very amicable agreement with Peter Tate, and I bought his licenses, a 2 and a 4 meg license, and filled in the forms, transferred them down to here. So that's how I've got the licenses. I think if they're there, you can transfer them. I think it's very hard to buy a license or space that isn't even there. But one thing, like being a ham, it's interesting. You know, when you come on normally, if you want to test or do something, you check, you listen to the frequency to make sure no one's on it or whatever. It's quite an interesting concept. You just come on. You know, I own the channels. You know, I'm paying for them. They're mine to use 24 hours a day for the next 5 years or something. So it's interesting. You just come on, you want to do a test or whatever. It's an interesting concept. You don't have to worry about anybody else. So anyway, that's the story how I got the licenses. And I've always thought, well, it'd be a fun thing to do. Run a broadcast. It's just a hobby. I'm not trying to make it into a big thing, and I don't want to get involved in, you know, a lot of stuff. And I think some people thought I was going to have, you know, a program department, a news department, you know, all this sort of stuff. It's just a hobby, you know. I just set it up on remote, and it just goes. And once I build something, I won't touch it until it breaks or whatever, and then I'll maybe do an improvement. I don't want to be, you know, a part of, you know, a slave to it. That's right. Yeah, when I first started, the licenses came through, and I just set up in the garage first, and it's a bit of a mess there, as you can see. But that was for the first few weeks. I had it running like that, and then that also included what's next? The old Geo9 transmitter. I used that for a while, but it was really bad because it had harmonics. It's link coupling. It was just rubbish. So I just used that for a while, and then I realized it wasn't tuned up to the third harmonic in 18 megs or something. And it was there. I thought, I don't know, not such a good idea. And but that's an 803 valve. It's a precursor to the 80813. So yeah, and I just used that tree, which was near the garage. I had antennas on that, a 2 and a 2.3 and a 4.8 meg dipole hanging off that tree. I've now got a few ham antennas. I you know, try and come on the ham bands occasionally, so I've got a 40 and 80 meter dipole and stuff there. So yeah. So anyway, I put all stuff in the rack nice and neatly after that garage stuff. Now, it's not as good as VNG Lyndhurst, but it's not bad, you know. I think it's okay. So that was the first incarnation of it. I like to have things in the rack and nice and neat, and so you don't get electrocuted and things, whatever. And always when you have a rack, leave a big space behind the rack so you can get in and get to stuff, because people put racks against their wall, and when things break down, then it's such a hassle to pull them out and they don't even, they have lots of dead stuff because they can't be bothered changing it. So anyway, that's the rack there, which I think is on that photograph on the website, the thing there. Now, yes, that'll be it. Now synthesizers. I've been interested in synthesizers for a while. This is an old synthesizer I got, so I can use that. It's not very good. What I find, I could buy a crystal, you know, I could, or get more modern synthesizers, but crystals are they're expensive, but you can get them. But anyway, the older synthesizers have phase noise, and if I'm running off the synthesizers, an old synthesizer sounds fine on the off-air monitors, not a problem listening to an analog radio, but on the SDRs there's a rumble, and people, you know, complain, so you only got noise in the signal, but it's only there if you're listening on an SDR. So it's not good, but you know, it's not an analog noise. It's to do with the phase of the way that the signal's generated with these ancient things. And that's the other synthesizer. That's That is a Singer, a very nice thing. They've got those sort of things at Radio Australia where you turn the knobs for the your decades and stuff, and you just dial in the frequency. So I've got that's a Singer synthesizer come test thing, but it's massive and it's all discrete components, would you believe? I've got another one that doesn't work, and I'm not even going to try and fix it. I might change modules or something, but it's beyond me. And it's, to do that back in the early 70s or late 60s, it goes up to 2 gigs. Incredible piece of equipment. And that's another Ronci or whatever. They're quite well-known test equipment. That's another signal generator. And I like the ones where you can just click knobs, because then if the power goes off or whatever, it can't lose its memory or whatever. It's locked in, it switches, and it just works like that. Well, of course, it can just have a modern synthesizer chip and just run it off a battery, as a standby. Now, the transmitters, the valve stages are just an output stage. And I used to, the Codan radios, which are fantastic, I've got a whole lot of them. I always pick them up at Hamfests. They've got 100-watt PA in them. So I use the output from the signal generator goes straight into the output stage of the Codan, just run a couple of watts of carrier, and then that have a matching circuit to feed the grid of the valve. So I'm using something that cost me $10 at a Hamfest to feed a bit of junk, and they work really well. Fantastic bit of equipment. So basically that's how the early stages are all solid state, and the last stage is a valve, mainly because that's what I've got, and it hasn't cost me anything. So that's a signal generator. Oh, that's a transmitter I got from Hamfest, John Adcock, 3ACA, who passed away about 5 years ago or something. That was his long wave transmitter on 173 kilohertz. So I bought that as Class D, quite a nice thing. But converting it to HF would be a bit of a pain, but it has got a nice VFO synthesizer. So I use that. That's probably the best one I've got. So it's just running off a power supply and a backup, gel cell. So it just sits there. So it's probably the most reliable VFO I've got at the moment. That's a close up of the. That's usually the two. Most of my transmitters run both. In fact, they'll run on 160 up to 7 megs. Basically, that's how I built them. But that's the 2310. That's the 4 meg one mainly, and it's got the Codan driver there that usually have the outputs at the back, a 50 ohm output, and I've got B and C plugs for the RF in and RF monitoring, so I can run a crow and plug into audio monitoring mod monitors. Another thing about power, if you run at 10 kilowatts and you're losing 5% of your power, to the listener, they won't even know. 5% out of 10 kilowatts is nothing, but that 500 watts is going to do a lot of damage. If a connector can catch fire or cables can melt, it can be a disaster. If you're using 100 watts and you're losing 5% of your power in bad coax or bad connectors, switches or whatever, the listener won't tell the difference. And the heat, if you touched it, you might vaguely feel a bit of, it's not going to do any damage. So this is the other advantage. Once you go up over a couple of 100 watts, you just can't use ham junk. You just can't use ordinary BNC connectors and coax and switching and all that. It means you've got to go into a new world of expensive and heavy and hard to solder stuff. So that's part of the reason why I've kept it down to power. I've done experiments running 2 transmitters on different antennas, like diversity transmission, which works quite well sometimes. And it does. Interesting fact, often the signal into Bendigo isn't very good because it's just the wrong distance. So it's quite good into Melbourne, but Bendigo, because it's being skywave, the 2 meg signal, and I was running for a couple of months. I had just a 50-watt transmitter running a vertical antenna on 2 megs, and it was much better in town here. Got through really well. and about 3 or 4 S points above the horizontal antenna. So it blew down the wind. It was just an experimental antenna, blew down the wind. So I'll reinstate that. But then probably no one's listening in Bendigo, so what's the heck? But I did notice it does increase the local range up to about 50k, quite a lot, having a vertical antenna on 2 megs, which is as you would expect. Even though we're like 20k out of town, it's got to come through the whipstick forest and everything, so it's attenuated, but not as much as the Skywave, which is just sort of going right over the top. That's another one of the standby transmitter, which I can use. It'll go on anything. Now, we're not totally antiquated. We have got, yes, let's see, here we are. Now, I'll just keep going with a signal strain, how things go through. Yeah. Now, one thing I found when I started doing transmitting on AM on 160 and stuff in Melbourne, to monitor your signal is really hard. You get a radio, it's just buzzes, hum with interference and modulation of the mains and all sorts of stuff. It's really hard to know how your signal is, unless you listen off an SDR, which is a good way of finding out. In fact, I had a remote monitoring station in the 80s up in the Yarra Valley, controlled by, it's a whole nother story I could do an episode on, controlled by DTMF on 2 meters, and I could, it was just fixed receivers. It was pre-SDR, it was just analog receivers. I could switch in, it was up 70 foot in a pine tree, and I could listen to my signal and do antenna experiments like I do now, and find out what works and what doesn't work. The only thing I had coming back was audio. So if I was doing test, I could just run low level modulation, a weak tone, just to listen to stuff would get through on you could hear, and do antenna adjustments and see if it got better or worse. And I do the same things now, and I'll tell you off the SDRs. But these mod monitors, fantastic. You plug them into your output of your transmitter, the monitor output, and what you hear is what you get. Nothing extra, nothing less. So these are the only things that, as far as I'm concerned, and they made a big difference once I got something I could actually hear what was going on. I don't have them turned on all the time because they take power, obviously. And I've got, that's an AWA N&D set, but it's the front end has got an RF front end, similar to those modulation monitors. So I can listen off that. I usually leave that one on and can listen to that on a speaker and find out how things are sounding. Oh yeah, now junk. I bought this at a Hamfest a couple of years back. It's a linear amplifier someone made at $60. I got it for, and I'm going to utilize this somehow. And so it's got two 813s. And yeah, really nicely designed. I'll have to change it to Class C because linear is a totally useless way of getting AM. It's just 2/3 your power goes in heat. It's useless. So I'll build a bias supply and get it going. Looking at the coil, I think it's on 20 meters, so I'll have to wind coils and stuff. But that's a nice project. And instead of running it on 2,000 volts, I'll probably drop it down to 1,000 or something, which is more than enough for what I need. I usually get valves. You run the screen as high as it can go and drop the HT so you can get a good oomph of power out without having, death-defying voltages. Not that you touch it, but, I don't really like anything over 800 volts, really. So some people are scared of valves these days, but, that's that's running at the moment, actually. That's an 807 transmitter I built. That puts out 150 watts. With about 600 volts on the plates. And yeah, it's a pretty simple device. Now, yeah, so I'm always testing stuff. That's testing see the rack was nice and clean, and you do all this testing, everything goes up the crap. So I'm testing a solid state transmitter there, and that's, I can spend hours doing that with all my equipment and, testing stuff, which, you can slap something together really quickly, like in an afternoon, it'll work. But to get it to work really well, that takes like 20 times longer. So the proof of concept, easy enough, but to make sure things are going to work and do all the testing, make sure it's going to last, isn't putting out spurious or whatever. It's a real I can see why research and development on equipment is takes so long on stuff. Now I'll just get back to oh yes, that's right. Now I modulate the transmitters from more stuff I buy at Hamfests. You can pick up like these 250 watt or even 500 watt PA amplifiers, and for $50 or something. Amazing things. And they've usually got tappings for 4, 8, 15, 20 volt, 50 volt, 100 volt lines, which equates to, in impedances, I think 100 volts is around about 100 ohms or something. So by manipulating just mains transformers, I use as modulation transformers, and you have a choke to, you don't have DC flowing through it. That's why modulation transformers are hard to get, because they have DC going through them, and they have to be specially designed so the core doesn't saturate and they don't work very well. So if you just get an ordinary, decent size mains transformer, and you put 8 ohms, say, of audio into the 6.3 volt winding, and use a 240 volt output, and you've got taps plus or minus a few percentage, use that to modulate your valve, and you have a choke to isolate the HT, so it's only audio going through the transformer, and the choke takes the HT, and you add the heighting modulation, basically added onto that. And all the transformers I've found have actually been, occasionally get one that's pretty average, but usually they are very good. Like I found, I've got a photograph of the transformer here. In fact, I have a list. I should have gone to my list. I can just look at it here and see what number it is. And it says 20. Well, there we are. Why didn't I do that before? There we are. So that's a nice big, it's a big 6.3 volt filament transformer. So I've got the output from one of those 200 watt amps going into the 6.3 volts, and tappings at the back, which gives me HT to modulate the transmitter. And they go, and that's the transformer down there. That's the choke. So it works well. And mains transformers, I found, they're obviously okay on the base end, because they work designed for 50 hertz. But the high end, they go right up 10, 15K. Usually they start to drop off around 7K. There might be 3 or 4 dB down at 10, which in normal practice is not for ham use, it wouldn't even worry. You can equalize them up and they sound fine. So there's, having a real modulation transformer is easier. Of course, you just have one unit. You don't need chokes and all this sort of stuff, and you just feed it in. And if you do have like a UM3 or something, or a modulation transformer, you can usually get a tapping on the back of the PA amps, one of the that'll feed into one of the, use them backwards and feed 600 ohms into, there's usually a 400 or 500 ohm tap on those transformers, and you can use it backwards and match into your valve. And because the amplifiers have got a lot of output, the audio amplifiers, a bit of mismatch doesn't matter. You can lose 10%. It doesn't matter. You've got 200 watts to play with, so you can, if there's any loss or mismatch, it tends not to be an issue. Now, if I look at PA amps, where is the? I knew this was going to be the worst thing trying to find. Oh, it's there. No. Anyway, the audio rack. Bear with me a second. Test bench. Here we are. Okay, I'll do it. Look. Fans test. Oh well. Oh, here we are. Yes, it's 11, there we are. No, it's not, it's 21. So if I look at there, so the audio rack is old, a lot of it's old ABC stuff, actually bought at auctions and things. So the audio goes through, I've got an Audimax, which basically is an AGC with, it's sort of smart, they're back pretty ancient things, but it'll plus or minus 15 dB, and it won't hunt. It'll sort of sit there if there's no, it won't just compress and make things sound terrible. It's sort of, it's like having an operator on the VU meter. It makes it a decision. It's got logic circuits in it. Makes a decision when to go increase the gain or reduce it. And I've got it following through this thing here, which is a bit of a compressor, a de-esser, which I don't use, but it has got a phase scrambler, because different people's voices and things have different. If you look at a tape or a recording, most people are asymmetrical, and a lot of music asymmetrical. So if you want to compress it and do things with it, it's best to make everything the same. So you can start at a 0 level or a reference level, and it goes through this Volumax, which has a way of having 120% upward modulation and keeping the downward modulation, so 120 up and 100 down. So that gives you a bit of extra boost, but it works better if you have a scrambled phase into it, because you don't have it. It's not working against itself, sort of thing. That's a multi-limiter, which was quite good, but stopped working, so I've taken it down. That's a band pass filter there. I can see it's on direct, which it usually is. And I think the bottom rack, yeah, I'm not using the Audimax. This is a newer thing. I think it came from MBS FM, and it's designed for classical music. Amazing range from, I think, 28 dB to -10. It's about incredible range. So it does the same as the Audimax, but it's got a bigger range, and it's even more smart. It's full of stuff. And I've got 2 of them, so if one pops, I can, I've got a standby. And it does a great job of keeping the audio constant, then it gets compressed in the other devices to give and the boost, so gives the other thing, and the other old limiters which work but aren't up to the standard of the other ones. Yeah, so we're talking about that. Now, if I've been doing work on solid state stuff, I was going to, one of the things I was thinking of doing is getting, say, a couple of 100 watts of carrier, and then getting double sideband, mixing it in. So then it's a good way of making AM, and do it all solid state. Here we are now. So I think this is one of my other test setups. Now that's the back of a TS440, I think, and whoever designed those sets is incredible. They can put out 100 watts, but of course if you try and they're linear, you get 40 watts of AM if you try or whatever. But I looked at the specifications and everything. If you run them at 16 volts and you push them to the max, the transistors actually still aren't out of their range of operating credentials. So they're not going to pop, but the problem is they get super hot and they won't work in that format. Like they'll put out 400 watts for 30 seconds, then they'll just turn off because the transistor gets too hot and it's got protection circuitry. But if you put super fans on them, as you can see like that, and I had that was running for quite a few months, putting out 120 watts of AM linear. Again, I don't like it because it uses more power than the valve sets, because but it's really convenient. Really, the stuff audio. In fact, what I've got is yeah, you can see how many fans I've got to have on it. That's why I like valves. I don't need fans. And you go in the container where the transistor things are on, the noise, you can't hear yourself think. The valves just sit there getting hot. They don't even care if it's summer because they get hot anyhow. Whereas the transistor stuff needs cooling. And now you build a balanced modulator, and if I think Peter Park is listening on the line, this is out of your one of your circuits, Peter. Magic things. You feed RF in one end, you feed audio in a socket here, and out the end you get, if it's balanced in the center, you get beautiful quality double sideband. That's how it's going to have double sideband and mix that in with AM. If you off balance it, you get really fantastic quality AM. Sounds fantastic. And that's what I was using feeding into the linear amplifiers, the solid state linear amplifiers. And it sounds beautiful, really convenient. And you can cheat a bit too, because depending on the power you put in and where you set the balance, you can have it so it doesn't over modulate as such. It just goes into sideband. So you can push the modulation more and it goes a bit, instead of splatting because the waveform hits the bottom line and you get a break in signal and it causes, spectrum anarchy. It just goes, if you do over mod, it just goes a bit sidebandy, which is a lot less, you can't push it that much, but you get an extra 10 or 20% by just cheating that way. And brilliant idea and simple to make. This is, if you want to make a simple transmitter, you have one of these and a little transistor or something, and you get a few watts of AM or double sideband, just a couple of 4 diodes and a bit of circuitry. There's an impedance matching thing there to get 50 ohms out, and pot for volume control and the balancing. So a great building block for transmitters and stuff. And anyone wants, getting double single sideband is hard. Double sideband is about the easiest thing you can make. And people will tune in, they won't even know you've got another sideband, and sounds fantastic. So that was the situation there. Now I think I think I've done most things, testing and stuff. Now I do a lot of testing with antennas. I put our antennas up everywhere, and which I can do. I've got the space. I don't really need, you don't need that much space. A dipole for 4.8 megs, it's halfway between an 80 meter dipole and a 40 meter dipole. It's nothing really. 2 megs a bit more difficult, but you don't need all that amount of space. It should come up there. Yes, it is. So I've got this patch panel. So I do different tests at different frequencies on 4 megs or 2 megs. I've got different antennas, different heights, different angles, different north, south, all sort of stuff. And I switch them with these. I've got a patch panel here and switch them with these, which I bought at the Shep Hamfest a couple of years ago, I think. Old Army or Navy, coax switches. And you dial up an SDR and you look at the, there's a facility, you can look at the S-meter signal strength graph going up and down or whatever, and you do switching in real time, and you can see if it jumps up or jumps down on wherever you're listening from, where the signal jumps up or down in real time. And I think it's fantastic. You have to be careful because you might do it. You've got to do a test over a few minutes because everything's changing. The whole ionosphere is changing. So you might, that's 10 dB better than the other antenna. Wow. Then you come back a bit later and it's 10 dB worse than the other antenna. So you have to, over a few days, a few nights, work out overall, I think this antenna's a bit better than this one. And the difference isn't much. Like a 4 meg antenna, 4.8 meg one, 20 foot above the ground is only a dB or 2 less than the one up 40 feet. It's better, but not that much better. And if you can only put one up 20 feet, it's still going to work. 2 megs, I probably haven't got, it's up about 60 feet. It could be higher, I think. But I've found, I don't know why, it could be where I am. It is quite mineralized ground, and apparently it is fairly good for RF because it had a lot of gold in it and stuff. There's all tons of old diggings and things around, so it's probably quite highly mineralized. Maybe all the gold is reflecting the signal up. But I found for 4 megs, east-west is best, and for 2 megs, north-south is best. Overall, I don't know, it could change, but that's what even the similar antenna, it seems to work better that way. And I've also found into South Australia, the vertical was better than the horizontal on 2 megs. Most times, sometimes it isn't. So I think with HF, you're varying, everything's varying. And, you know, sometimes 4 megs is really strong into Melbourne and it'll just turn off. You think, oh, something's gone wrong. No, it hasn't. It's just you probably, you know, you've been on 40 meters and someone's talking and they're just gone off in the middle of a QSO. What's going on? It's not, the equipment hasn't stopped. It's just that in a second, the conditions have changed totally. And the same thing here. So that's the antenna switching thing. I'm not a big fan of SWR meters, but I usually have them in and I try and get the antennas to match vaguely. It doesn't matter because I can tune up the transmitters or the valve transmitters for any impedance really. But it's nice to be able to say, you walk in, oh yeah, they're there, nothing's gone wrong, everything's okay. If they're a bit off, think, oh, you know, antenna's fallen down or something's happened somewhere, or, you know, kangaroos ripped out the, you know, the coax or something. So I just have them there as a backup to see what's happening. They don't mean anything except that 0 is about what it should be. And you get some idea of, like, our voltage there changes from about, you know, 240 down to 100 to 200 volts. So, you know, some nights it's much less power than other nights. What's a check in there? Now that's one of my trees. I've got an antenna in. It's not much of a tree. If it was in your backyard in suburbia, you think, God, that's a bloody big tree, you know. But when there's a million other trees, that's probably 60 feet, that, which is pretty good, you know. I mean, put up a 50, 60-foot pole in your backyard, you know, hard thing to do, and people complain. So that's a 4 meg dipole hanging off the tree there, and that's a close-up. I've just got ropes so I can change them and stuff. And I've got spare antennas in case they blow down, because they're not, you know, they're not going to last 100 years. So I've always got spare transmitters and spare antennas in case something goes wrong. There's, I think, another view of another tree, or the same one, I'm not sure. That's you can't see that, but that's the end. That's the end of the 2 meg dipole, and it goes into a thin rope there. So that's in another tree, one of the 2 meg dipoles. And this tree here, it's got a dipole in there. I mean, that is actually a massive tree. Because it's got other trees around, you don't notice. I have bigger trees down. I've got a nice outback creek, which is about 500 meters north of this. And it's got some beautiful big trees, massive things. But there's no power there. And, you know, I could maybe build a solar panel and have a transmitter there, but whether it would be any better than here, I don't know. I haven't tried, but another thing I'd like to do is put a receive antenna down there and either have coax come back or have it SDR controlled so I can receive stuff when I'm on air. It's a bit of a problem. In fact, I wouldn't want to be a ham. Like, I did a survey on Google Earth. I think it's about 15 houses within a kilometre of my place. The nearest is 300 metres. So, and I've got antennas, no one's a ham, they will listen to FM or satellite, no, there's no problem. But if I was running 200 watt transmitters 10 hours a day in a suburban area, you know, it'd piss people off big time. I mean, if you're a ham and there's this crap coming through, you know, and what I've noticed is when I come on, the noise floor goes up about 10 dB across the spectrum of everything. And so that's why you need it. And if I was a ham living next door, I'd be pissed off. And that's why I think when they give these licenses, they do look at where it is, and they probably not going to give it to somebody in a block of flats, in a farm or something. Yeah, that's okay. They probably do a survey like that. But yeah, so basically it's a beautiful quiet. There's no noise at all. It's just a fantastic area for listening. So just when I come on, you can tune around, it's fine. Just there are spikes from harmonics of the transmissions. There's 2 of them and all that sort of stuff. But, you know, maybe if I get get a receive antenna further away, it might be okay. Now this tree's, it's interesting. Always be careful of trees. In summer, I was looking at this tree to put this antenna in, and I was walking around looking at the tree, and I was standing just there. And I was looking, that's a big tree, yeah, I'll put the antenna there. And then I walked around to this side of the tree, and then I was looking up and I heard this crack. And I looked up and this whole branch broke off here and fell down there where I'd been standing 30 seconds before. And I thought, I've heard about that on hot days, trees can just drop their branches. So, I'm careful now with trees. I will walk under them. I love trees, but I won't stay under one longer than I have to. And the house is in the middle of a paddock, a long way from trees. And we had a massive tree in our backyard in Caulfield. And it's every storm I was paranoid I was going to, and it fell down, smashed the neighbour's house. So horrific. So I just don't want to be anywhere near trees. People build houses under trees. I don't know. But anyway, that's what's a bit of a scary campaign there. And that's the container before I put stuff in it there. I wonder if there's any other interesting photos I haven't shown yet. Balanced mixer. So basically that's it. Like, I'm just doing it as a hobby, really. And I've always liked to experiment with stuff, particularly antennas and things, and also building my own stuff. And I know I should be building a Class D transmitter or something like that. But I haven't. I've got other things to do, and this is working. It's working. I could build two 400-watt transmitters and take the same power I'm using now and have that. Although it's not quite as simple. Of course, these transmitters, they say, you can get, Class D, you put 99 watts, 100 watts in, you get 99 watts of carrier out. See, that's fantastic. The efficiency is amazing. If you're modulating it and you're getting 100% modulation on AM, that's 400 watts PEP. People don't forget that. So that power isn't made magically. You're paying for that as well, even in a Class D transmitter if it's fully modulated. So, and the valve stuff, they're 70% efficient. Even with the heaters involved, they're not bad. Because if you're running 10 kilowatts, then the loss is going up as well. If you're running 100 watts and you're spending 70 watts on inefficiencies in the valve, well, it's not a big deal. So basically, I think I've covered it. It's not so bad. So any questions that people would like to? Well, that's whole other thing. Some of these stations just play like an MP3 player, whatever. I've always been interested in radio and broadcasting and stuff, and a history of broadcasting. So I've basically trolled the net, and I wasn't going to be this way. It's ended up being, I've got old air checks from a lot of Australian stuff. Old Peter Evans program from the ABC, stuff like that, and music programs, Top of the Pops, Kenny Everett from the UK, other things, weird stuff, old programs dating back to the 50s from the US, old pop hit programs and stuff, fascinating music, and I've got them off the Internet Archive and the internet. Plus, I've had a massive collection of tapes myself. I recorded off radio back in the day when and then when because people used to collect tapes, a lot of people who worked in radio or TV, they'd collect tapes or borrow tapes or whatever, and when they left or they got moving house, I've got a room full of tapes, you just take them. Fascinating stuff on them. So basically the program material, sometimes I just play music, but usually it's a program. And there's a lot of really interesting radio programs, college radio programs and things that we don't really have here, but interesting music. And I play a wide variety of stuff from, generally the peak hour, which I think is like at the moment, say 5 o'clock in the afternoon till 7 o'clock, where the propagation condition is just fantastic. I play more popular old hits or whatever, hits programs, things. Then later in the night, it might get more esoteric, bit of classical music, some old time stuff, from 78s, progressive rock, jazz, cool jazz, stuff like that. I've got a really, there's not really much music I really hate. And I like put stuff on. So basically that's what the programming is. And I probably spend more time working out the programming than technical stuff. We'll talk about that. As I said, you'll find the filter on that thing is in the direct setting. Look, 100 watts. All I'm going to interfere with is China. Well, in fact, on 4 megs, I'll interfere with KCCW, whatever it is, Nashville, which is 5 kc up. It's a religious station. They broadcast, sermons and things. And they're in Nashville. They run 50 kilowatts. I'm not going to interfere with them. They're often quite strong. I've looked at the Nashville SDR. I'm there, but I'm not interfering with them.
As a listener, how
it's hi-fi. It's whatever is on the program material. There is a band, like you'll notice these sort of like normal AM stations, 18 kc, 9 kc audio bandwidth, which most people over 50, their hearing over 10 kc is highly compromised usually. 9 kc sounds fine, sounds like fantastic. If you like, I remember when I was working the ABC I had these filters. You switch in 10 kc, it sounded crap compared to wideband, but now I can't tell the difference between 10 and 15. 10 to 8, I can sort of tell the difference a bit. But say most of the people in this room, if you put a signal generator to your ear, you'll be surprised. 10 kc is about your limit, unless you turn it up really high. So I'm basically running. If you find most of the stations not on the AM broadcast band, like the ones up the top end, the narrowcast stations above 1603, they've usually got a 6 kc bandwidth, but you'll notice most of them don't worry about it. I think the ACMA had to say something. Oh, we'll make it 6, but basically people run what they want to. And there's not like I've got an adjacent channel, 2 megs particularly, there's just no one anywhere. Well, that's another issue. You'll find that for a start, I don't make any money out of it. And theoretically, the music itself is one thing. The programs are so old. Is someone going to complain because I'm playing a BBC or an ABC program from 30 years ago? Who cares? And the copyright issue is it's not. There's a broadcast services band, which is from 531 to 1603, and the FM band and the TV bands. Now, the stations above the broadcast band, they can pretty much, like the 1611, 1629, all those, they can basically do what they like because they're not covered by the Broadcasting Act as such. Same as the stations below 88 megahertz, the small ones. I think they're not covered as well. And these shortwave stations, they're sort of like in a no man's land. So all you need for these stations is an apparatus license. Whereas if you want an FM license in the real part of the FM band or the real part of the AM band, you have to get the apparatus license, which licenses your transmitter and a broadcast license as well, which is a totally different thing. Say like the broadcasting license for a metropolitan station, the apparatus license is probably a few $100s a year, but the actual broadcasting license is more. It's all in the Broadcasting Act. It's all complex. I can never work it out. But yeah, I think these niche low power stations are on a different sort of thing. And I think the copyright people could push it if you are stupid or something, but what are they going to get, so that's what I'm thinking. There is a license. You can get a copyright exemption for a community station, which is only a few $100s a year. But then I'm not a community station. So, I'm under a totally different thing. And all these other stations, these weird stations below 88 megahertz and above the broadcast band, they basically do their own thing. Because I know no one's going to listen to them. There might be 10. It's a minor interest thing. So that's the issue there. Well, I'll tell you what, if you're listening on the SDRs and you go, it's got AM, narrow, medium, wide, and it's got synchronous detection. And if you hit synchronous detection stereo, because particularly on shortwave, it's all over the place. It's quite fascinating to listen to. It really is like a false AM stereo. Yeah. And if you listen in IQ is interesting too, because that has a different effect. Quite a weird effect. So in stereo headphones, so it's worthwhile doing if you want, or any AM station on an SDR, on those funny modes, you can get some interesting effects. So basically, the quality is, the quality of the amplifiers and the transformers, it's well above hearing range, basically. Yep.
So, this is the feedback. Can you get much with the feedback?
I'm surprised at how little I get. Basically zero. When I first started, I got a little bit because a few people publicised it. And, I put up a web page, I put up a Facebook page. I've got an email address, vl8k@outlook.com. Very little feedback. I get the occasional DX person from overseas that says they've heard or seen a trace of my signal or whatever. Basically, I'm surprised at the lack. I think, look, I was an avid radio listener for years. I listened to weird stations. I never rang anyone up or wrote them a letter. So I'm assuming there might be someone listening. Maybe not. Well, some of the DX people want a QSL card, and I'll write them an envelope. But I just say, look, take this email as a QSL card or something. What am I going to do? Send a card and hop in the car and drive up to Raywood and post it in a letterbox? I mean, it's ridiculous. Yeah, it is, I suppose.
It's like getting QSL card.
Yeah, well, mate, I got someone from Alaska the other night. They'd heard me there. It's like when the ABC had these frequencies running 50 kilowatts, they're worldwide, basically. You can hear them in North America, Europe. It's no problem. So being 30 dB down, is a difference, but it's not impossible to hear them overseas. And I would have thought there'd be more interest in the DX community. I'm surprised there hasn't been. So maybe this lecture might spur people on to do stuff. Yeah. Look, people do, and you don't have to. I don't expect people to go and say, "Oh, that's fantastic! Every day, you have a great show, great music, great signal." I mean, I don't. In fact, in some respects, I don't like compliments. It's weird. I feel a bit funny, and then if people compliment you on a certain program style, and think, well, maybe I should do more of that. But I really want to do what I want, And if the music I don't want, I won't play it. If I do, I will. I make the odd announcement. There is a mic in the shack there, and it's on auto close down, but sometimes it doesn't. I forget to turn it on. I go up there and I might say we're closing down or something. Or if there's a fault condition, I'll go up and say, look, 4 megs will be off the air for a couple of minutes while I change to another thing, and I might rave on a bit. But basically, I don't do many programs. There's a few air checks when I used to work in commercial radio at 2RG, which I put in occasionally. And I've done a few programs, but basically other people know more about stuff than I do. So I let them talk about it. Got some old jazz guy talking about jazz in Chicago in 1950. He knows more than I do and knows. So what could I do? I can't advance on that. So basically, in some respects, it's a bit of an outlet. I don't really care if no one's listening, really. It gives something to do. It gives you a reason to do this experiments. You don't have to have a license. You can just come on the air and talk on the air and do stuff on the various bands and get air checks, check your stuff on SDR. Fine, that's great. But this it gives a different aspect to it, and also you build the stuff and you see how long it lasts. I mean, these valves, they're the same valves in the stuff when I built them in the 1970s. Still there, still working, and there was Valve Studios at the ABC in 1985 that were built in the late 30s, moved to Broadcast House in 1942, and they've got, there's they're pre-octal. They were pre-octal valves, the 5-pin things, and they're still running. No one ever touched them. They didn't want to do anything. Just don't turn it off. Just leave it on, and they're running for 40, 50 years. Incredible. And and I've got so many spares, I'll never run out. But, transistor stuff, I'm quite happy that it works okay. So it's just a bit of a fun thing to do.
In terms of the program, you thought of also including amateur radio type programming, as in maybe relaying news or something?
Well, they do a pretty good job of relaying themselves. Yeah. I think a lot of the people who'd listen would know about ham radio. I'm not broadcasting to the general public who just don't know. Funny thing is, you look at this graph here. They say shortwave's dead. Why are people spending millions of dollars to have massive signals on the bands? Someone's listening. So in Bangkok or Thailand or whatever, people listen to shortwave. But I'm just it's another medium. I'm more for the hobbyist, hams who might tune across and hear, or someone a DX person. Oh, there's a local station. Well, main reason I put it up, I thought, well, you can go to buy Digitech radios and stuff. In fact, at the Bendigo Electronics, I saw they used to have quite a good selection a few months back. The big Digitech, the smaller one, and the little ones, and all that sort of stuff. And there's might be one here. They are fantastic little. Oh, that's not my bag. Sorry about that. Yeah. So I mean, you can go and buy this, for $110. Amazing radio. And because even if you're in a noisy area, you can put the antenna up and you find a quiet space in your backyard and you can listen to stuff. And I thought this stuff's on the market. We should give people something local to listen to. And I noticed that the local electronic shop, they've only got this model, I think, and lower ones. Someone should tell them that there's a local station and they should promote it and maybe they're just out of stock. But basically, there's so many good radios you can buy now that cover shortwave, and they cover the whole band, from DC to daylight almost. And the old-fashioned, they buy at Hamfest, the old, Sony portables, they're really good radios. So, yeah, mainly to put it on so people they tune in. I've got shortwave, all I can hear is funny noises and people talking in Chinese. And if they hear a local program, they might be inspired to listen a bit.
General question. When radio Australia closed down,
Mm.
what did that have on more remote areas in Australia? Were they very remote?
I think the domestic shortwave, like from Alice Springs and Catherine, yeah, people, well, there were people that was their source of listening. I mean, you got drovers and stuff. They haven't got satellite dishes. They had something like that. And they get out in the morning, make their cup of tea and turn on the radio. And I remember I drove around Australia in 72 or something. And there are you're out in the outback and the car radio is full of stations at night. And the sun comes up and slowly they just disappear. And by about, an hour after sunset, nothing. The whole band is just hiss. There's nothing. It's a bit better now. They put some high power stations in, but still there's a lot of places that have either just one very weak station or no station. So there are parts in the mainland of Australia, there's no daytime terrestrial broadcasting unless part from shortwave. So it did make a difference, but they couldn't care less. And in fact, Michelle Guthrie, who was the CEO of the ABC, if it wasn't for her, they'd still be on, but then I wouldn't have these frequencies. But anyway, she was from Google and she wanted to digitize. In fact, they sacked her because she was incompetent and they got rid of her eventually. But her plan was to get rid of AM and FM basically and just have DAB and all the stuff. So I didn't actually speak to her because I was working at South Bank at the time as a freelancer, and she was in to open a studio they'd built or something, and there was all these dignitaries and the Minister for Communications and all sort of stuff there. And anyway, I don't think the staff were meant to go in, but I went in, and they had champagne and stuff. So I had a few drinks. I thought, no, tell this woman, what. So I walked up to her. I think she was talking to the minister or whatever. And I said, Michelle, I'm, Dave, I'm cameraman here, and blah, blah. I used to work a few years back and stuff. And I said, look, turning shortwave off is a bad idea. People out there. And look, she listened to me for 5 minutes. And I said, look, I don't think you understand. Out back there, it's a different world to the city. It's really basic. And it's not the people in the towns and the communities, it's the people who aren't just in nowhere. And I said that they need the service. And oh yeah, but digital's a way and satellite's a way to go and all sort of thing. So I tried to tell her. So I think they were happy just to let it ride along. It only, like the inland service only cost a couple of $1 million a year to run, just the power bill. They owned it. They owned the equipment. They could set up a Pacific service. They've got the land. They've probably got land with unused towers on it. They could put up some arrays. They've probably got the equipment. They could do it for the power bill. But there's some political reason they don't want to. And New Zealand now is covering all that area. A little country with one transmitter, and we had a whole paddock full of stuff turned off. It's crazy. So who knows what's in the mind of politicians? They've got some idea, but so yeah, it's just doing a little bit. I suppose it's a bit of a. It's fun to say you run your own radio network. Oh yeah, listen, I should take questions from the remote areas.
Yes, a couple of questions from Zoom people. From Jim VK3ASE. Could you do away with the mains transformer you're using as a modulation transformer by taking the 100-volt output from the redback amp? You'd still need the choke and coupling cap.
The problem is the impedance has to match to a few thousand ohms for the valve. You could do that with a solid state transmitter, but you're looking at it, the impedance is too low. You could do that, but you need some So you need to, what's you work it out current at voltage to the valve. It might be 2,000, 5,000 ohms. So you need not 600 ohms. You need 5,000. That's why.
And another one here from Chris VK3AML. Ever thought of running a broadband single sideband from an SDR kit or linear amp like a Hermes light exciter?
Like a what?
Hermes light exciter.
What, run sideband or run AM?
Broadband single sideband.
Broadband single sideband is all very well, but the problem is to get good quality, you have to be phased, the audio has to be phase locked to the carrier. And that means, people do play around with high quality single sideband. It's probably great for speech. It sounds a little bit off, but you can be exactly on the same frequency, but particularly with music, it can be a fraction of a phase difference off, and it sounds crap. Music has to be exactly in phase. And that's why, if shortwave had gone, 20 years ago to single sideband with a pilot carrier to lock in the thing, it's a lot cheaper to transmit double sideband or single sideband. But the way thing is, most people have radios like that, and they're not going to get the benefits from hi-fi sideband without the carrier there. It's a nice thought. It's the same DRM, I like to experiment, put DRM on, but in real act, how many people got a DRM radio that you know? Nobody. And it's not as robust as AM by any stretch of the imagination. So yeah, I think we're stuck with AM until it totally fades out.
And a couple of people have tuned in during the talk.
Right.
And for example, Dave VK3ASE noted that 2310 is being received in Bendigo at S6 at the moment.
Oh, good. Yeah. Well, if I get the vertical going, it should be a bit better. Put that up again for the local people. But if then no one's listening, it's just a waste of money, I suppose. But I suppose I'll do it. It doesn't cost much, another 50 watts. I think the thing is, unlike a local station, a small local station, like if you're talking to Bendigo, that's it. But if the audience is Sydney, no, it's really strong everywhere. Even in Western Australia, the SDR in Perth is crap. The one that the public one. There's a few non-public ones I've got access to top grade, and the Perth one, it's just booming in on both frequencies. Same in Brisbane. There's a non-listed one in Brisbane, and the listed one, it's pretty marginal. The other one, it's got proper antennas and stuff, and it's just massive signal. So I think it covers probably, easily 1,000 K around on a good night. Yeah. Any other questions from the? Oh, okay. Yeah. Ballarat would be good in Ballarat. Yeah. There's an SDR at Ararat, and he gets a booming signal. Obviously, it's further enough away. I mean, if I moved to Pyramid Hill, you'd probably get a good signal here. But I've got a radio in the car and a helical antenna. If I drive anywhere, drive to Melbourne, I usually have a listen. Interesting fact, if I drive down the Calder or whatever, it's quite listenable all the way into the city, and you go over the West Gate or the Balti Bridges, and there's a crackle and static. As you imagine, in an industrial area, it sounds a lot of interference, but it's listenable. Drive up Dandenong Road, and then when you drive into the suburban streets, it disappears. The signal disappears. There's something in those suburban 240 volt lines that's just a white noise that just kills the spectrum. And if I go to my old place in Oakley Road in Carnegie, out the front, you can't even hear it. You go out the backyard with the little, Digitech, put the antenna up away from the power lines. It's perfect. As you walk up towards the power lines, it's not noise. It's just there's nothing there. There's some interference just ruining everything. And I think a lot of people, they turn on the radio, oh, no, there's nothing on shortwave, nothing on medium wave. Of course, they're in a noise zone, you know, terrible. I don't know how bad, if Bendigo's got a problem like that. But yeah, probably all of them. Yeah, that's right. It's all this digital noise that slowly adds to the 1 or 2, doesn't matter, but it's yeah, it goes it's like what a crowd shouting in the MCG you can't hear. If 100,000 people shout, you can hear them over the other side of the town. You know, it's the sort of every little bit adds up to it. So and I know a lot of people in the cities can't hear it or whatever, but you know, then I would have to run another 30 dB, but it's not going to happen because I'm not going to spend $100 a day on power. I would like to have solid state stuff, get some cheap solar panels from the Eagle Hawk Recycling Centre, basically go for nothing, get some batteries and run it off solar. I mean, battery prices are getting quite cheap now, lithium batteries, or even go old style Edison nickel iron batteries or something like that. So you could, you know, charge up in the daytime and then run at night. The other thing I'd really like is a higher frequency that would work in the daytime. You can hear it in Melbourne and stuff, but it's not for communications. It'll be fine, but it's not good enough for broadcast. You need at least 20 to 30 dB over. If I had, 7 megs, 8 megs or something, it'd boom in over there. You know, it'd be a beautiful daytime signal through most of Southeast Australia. Trouble is that it's a bit hard to get that. We are working on them, but because it's over 5 megs, the ACMA, they've got to liaise with the ITU. It's not as easy as below 5 megs, but you know, that'd be, and you can just run 100 watts. It'd be fantastic, you know, on those frequencies. So yeah. So any other questions? I guess we all go and have a copy. Yeah.
I think it was a last year. I didn't read that.
Yeah. Get a few calls from Alaska and northern Scandinavia. Those cold places maybe, but yeah, it's pretty good. Well, there we are. I won't bore people anymore. I went longer than I thought, but yeah. Oh, thank you.
Question I didn't ask, I thought, was do you take requests?
I would if people send them in.
Thanks, man.
All right.
All right. Well, what is it? Turn it on.
That better? Okay. Well, that's all from us at Bendigo East Hall, the Bendigo Amateur Radio and Electronics Club. We hope you've enjoyed this evening. And our best regards to everyone on Zoom. We're all going to go and have something to eat next time. Oh, right now, if you want to join us next time, we'll be very glad to see you. So from everyone here in Bendigo, 73s, VK3 Charlie Mike Zulu is clear. Good night.